Okay, so the next topic is how to interpret a DEXA scan. So this may be quite simple for some of you, and it may be not so simple or useful for some other people as well. So I'll do it from the basics just so that you fully understand it. Obviously, different trusts, they report the scans differently. Here at Imperial, we have not a very thorough reporting system, I would say, for our DEXA scans. It doesn't take into account some of the inaccuracies in DEXA scans. So definitely people who come to my clinic, I try and get us all to look at the actual DEXA images and the full sort of 4-page report so that you can understand what all the nuances are. Okay, so one of the most important things to remember is that we shouldn't get so obsessed, well, we should in a way, but not fully obsessed with the DEXA scans, because bone strength is made up of several things. It's not just the density of the bone. Okay, so here in blue, you can see bone mineral density. That's obviously one component, but then you also have the microstructure of the bone, so which can be assessed in using trabecular bone score on DEXA scans, but most DEXA scan machines are not activated for the trabecular bone score. And that basically assesses how it takes a zoomed in picture of one of your trabecular areas and sees how similar to a chessboard it is, essentially. So a chessboard is meant to be the whites and the blacks are laid out in a very strong way. And if it's very irregular, that's a poorer textural score, which means worse microstructure. Diabetics, for example, have quite poor microstructure. Then you've got the biomaterial properties of the bone, and then you've got the geometry, so the angles at which the different bones interact. So there you've got 4 different things that all comprise bone strength. So bone mineral density in itself probably makes up about 50% at most of the bone strength. Here you can see a list of the possible ways that we can measure each of these. So bone mineral density, of course, we've got DEXA, and in some research settings we can use CT. Microstructure is the trabecular bone score, which can be done on a DEXA machine, and is also available on research CTs. The biomaterial properties of the bone can only really be assessed by a bone biopsy, which is very, very rarely done. The geometry, you'll probably need an engineer to assess that properly. Okay, so the message here is DEXA provides up to 50% of the information on bone strength, so don't get completely hung up on it. And there are other factors involved. And it's important to remember as well that obviously DEXA is our most commonly available measure, so it's all we really have on a day-to-day basis. Okay, so here's a DEXA machine. So you can see the patient lies on a bed there, and there's an arm that goes up and down the patient to get the scores, and a technician who's sitting at the computer there. Now, you may worry about, oh, how much radiation is this? We're going to repeat the DEXA scans every 2-3 years or sooner, but in actual fact, it's only 3 hours of natural background radiation in comparison to a CT in the chest, which is 2 years, and a spine X-ray is 6 months. So really, it's a trivial amount of radiation when you have a DEXA scan, so you can always reassure your patients. Okay, so T and Z scores. So I've had a discussion with a lot of people over the last few years about the difference between the two and when to use which, and I think a lot of people still probably use them inaccurately. So T scores are designed to be used in postmenopausal women or men over the age of 50. And in some cases, you can use them if a patient has had a fragility fracture, because that means they do have weak bone. Okay, I'll come on to why you should use T-scores in this setting a bit later. Okay, but essentially T-scores only in a postmenopausal woman or a man over the age of 50, which is sort of the post-andropause man equivalent, or fragility fracture. So you've got the normal, which is -1 and above. Osteopenia and osteoporosis, as you all know, is -2.5 or less. And severe osteoporosis, or some people call it established osteoporosis, is when you've got a T-score of less than -2.5, as well as a fragility fracture. So remember, a fragility fracture means a fall from standing height or less, okay? So it's a fall that you would not expect someone to fracture in. So a severe osteoporosis is a T-score of less than -2.5 with a fragility fracture. So the importance of this is that it means that that low T-score does translate to fragile bone, okay? Because now you've got the clinical evidence that they're fractured easily, so that means that that T-score is even more important, okay? Then you've got the Z scores, which are age and sex matched and ethnicity matched. And the normal here is -2 to +2. And a low bone mineral density for chronological age is the Z score -2 or lower. Okay, so it's -2, not -2.5, it's -2. And we call this low, we don't call this osteopenia, we don't call this osteoporosis. We call this low bone mineral density for chronological age, because that's all it is at this point. And if you do have a low bone mineral density for chronological age, that essentially should trigger in your mind, is there a secondary cause? What else could be going on? Which takes me back to the last week's session where we discussed how to approach the patient and look for secondary causes of low bone mineral density. Okay, so moving on. Why are we not going to just use T-scores? So here is a graph of 5-year fracture risk on the y-axis. So how likely they are to fracture in the next 5 years, according to age, between the age of 50 to 85, for different levels of T-score. So a T-score is comparing your bone mineral density to that of a 30-year-old female. Okay, so as you can see here, in the later part of the graph, as you get older, your T-scores, for different T-scores, they separate their risk. Okay, so you've got -3.5, -3, -2.5, -2, -1.5, and -1, and they all spread out as you get older, which means that having a T-score of -3.5 as opposed to -3 at an older age has a massive impact on your fracture risk. But if you go backwards, okay, so before 50, these lines all merge into one. And so the difference between different T-scores has very little impact on the actual fracture risk because they will all converge together. Okay? So that's why we use Z scores classically before the age of 50 in men, or menopausal age in women, the average of which is about 51. Because Z scores just tell us about the is age matched, and T-scores are just comparing it to a 30-year-old female. Now, the way osteoporosis was initially defined by the World Health Organization in the 90s was basically what they did is they said, okay, out of 1 million patients, 1 million postmenopausal women, what percentage in this 1 million cohort of women have had a fragility fracture? And they said the number is, let's say, 30. Okay, so 30, we need to set the T-score, which will catch 30 out of 1 million. And so that's how they set where to put the T-score. So it captures the equivalent number of people that would have had a fragility fracture. Now, it's important to remember that because osteopenia is much more common and normal bone mineral density is much more common, actually most fragility fractures happen in the osteopenic cohorts and the normal in terms of numbers. Okay? So the reason we have set a T-score, we use T-scores, is to define osteoporosis. Because if we just use Z scores, you'd miss the natural progression as men and women age to very low bone mineral density. You wouldn't know when to start classifying it. You don't even know when it was low for chronological age, which it may be, if you're 110, you may have normal bone mineral density for chronological age, but you will have osteoporosis, almost certainly. Okay, I hope that is fairly clear to everyone so that we can all get into the habit of using T-scores for these postmenopausal women and for men above 50, and Z scores for everyone else. Now, it's important, Z and T scores are very similar between the ages of 30 and 50, okay? but we should really be using Z-scores before that. And then using T and Z scores at even younger ages, so when men and women are 20, 25, is slightly risky because they're yet to achieve their peak bone mass, which is typically around 30 years old, a bit later in the Asian population. Okay, I am moving on. So here's a DEXA scan. Okay, it's a 72-year-old female. Here is the spine, which is all drawn out by the radiographer. Okay, and then you've got the hips on the other side. Okay, so let's look at this box to start with. L1, L2, L3, L4. So that's the individual vertebra, which have been separated. And you get grams per centimeter squared. So this is an aerial measurement, okay, rather than a volumetric measurement. So immediately you can understand that if someone has big bones, as in they're a larger person, versus someone who is usually under 150 centimeters, then there will be a slight amount of error because of the amount of bone behind the camera. Okay, which can be corrected. There is a way to correct it, but is not that often used. Okay, so then you've got the T-scores for each of the lumbar vertebra, and at L2 to L4, which Imperial we set as our overall mean. And so here you can see minus 2.6, and the Z-score is minus 0.9. Okay, so it is 72-year-old, so we can use T-scores. So it's osteoporosis at the lumbar spine. The Z-score shows it's actually normal for age and for chronological age, in fact, but she's osteoporotic. Okay, and then here you can see the trend, which is a comparison between this current scan performed in August 2019 versus the 2015 scan. So you can see there's minus 0.7, so 0.7% loss of bone mineral density in the lumbar spine compared to 2019. And then you can compare it to baseline, which is the first ever scan they had, 2009. So compared to baseline, she's lost 7.8%. Okay, now there are errors of the machine, don't forget. So it's something called the least significant change, and that is approximately 3% actually at the spine and about 4% at the hip. So there's quite large errors in this technique. So when we see minus 0.7, we don't think, oh, there's a drop there. We say, probably, this is probably stable. It's within the error of the machine, really. Okay, so you're looking for 3 to 4% changes to definitely mean that there has been a clear, significant change in density. Okay, and then in the hips, you get the neck and you get the total. So on the reports at Imperial, it's the total that's put in. But when I come on to FRAX scores, I think in one of the future sessions, I will remind you that you should put the femoral neck in. So the femoral neck is this small rectangle here, as opposed to the total, which covers all the hip. Now, different people say different things about which is more accurate. Some people say the total is more accurate because it provides a bigger area, so less susceptible to error. But the majority of people say that the neck is probably the most accurate because it's a very small area and quite easily definable. Okay, so that's the spine and the hip. Now, if we look at this spine here, T12, L1, L2, L3, L4, you will see, oh, there's a big white splodge here on L4. Now, that's obviously degenerative change. So that is osteophyte formation. And anything that is white will essentially falsely elevate the apparent bone mineral density because all we're measuring is how white the bones are. So when you look at a vertebra, you want to see it nice and symmetrical. You want to see that the T-scores per vertebra are within approximately 1 standard deviation of each other. If they start to jump, as does the case here, especially to L4, you can see it's suddenly gone to minus 1.8, the T-score. So you then look at the film and you think, oh yes, there's a big white splodge there. I think the L3 is probably okay to me, even though it has jumped by a fair amount from L2. So look at L4 and I say, okay, that's a bit of a vertebral inaccuracy there. And so what am I going to do about that? Well, if you look in the other page of the report, you will see this very helpful table where not only do you have each vertebra on its own again, which is what we saw in the previous table, but here you have different combinations of vertebra. Okay, so what you want to do now is ignore L4. Okay, and you just want to make a diagnosis based on L1 to L3, which look fine. Okay, Now, you can't make a diagnosis unless you have at least two vertebra. Okay, so L1 to L3, you can see here the t-score is minus 3.4 and the z-score is minus 1.7. Okay, so if we go back here, you can see the lumbar t-score on your report will say minus 2.6, but actually, more accurately, we should be using L1 to L3 and say that t-score is minus 3.4. This can make a big difference, especially if you're deciding on treatment options and if they fall under the NICE guidance, for example, for teriparatide. Okay, so the important thing here is to consider different forms of inaccuracy, especially in the vertebral films. So this is a vertebral fracture you can see here. You can see here generalized degenerative changes. You can see in this last one a vertebroplasty where cement has been put into a vertebra for vertebral augmentation, probably because the patient had a lot of pain. Okay, so the next thing to consider is that if we're just going to look at L1 to L3, how can I compare this to a previous DEXA that the patient had, where how can I compare it to a previous DEXA the patient had? So what you have to do here is you probably have to do a manual calculation, because the computer will automatically do one on L2 to L4, but it won't do one on L1 to L3. So you can just take the raw number here, which is 0.764, and compare it to the L1 to L3 on the previous scan and work out the percentage difference by taking one away from the other and then dividing it by the first, the prior L1 to L3 bone density. Then you get the true change in bone mineral density in that section. Okay, because sometimes a patient may suddenly develop this arthritis in their spine, and then you may say, oh, look, the L2, L4 is much better now, but it may just be due to new degenerative changes since previous. Okay, so message here is, so beware false elevations due to degenerative change, and choose your vertebra and your T and Z scores appropriately. Now, finally, moving on to the hips, you can see the femoral neck and the total, okay? And you can see again the change versus their previous scan and the change versus their first ever scan. So this patient's lost 12.5% since their first ever scan, has lost 1.6 since their 2014 scan. Okay, for FRAX, we're going to use the femoral neck. Okay, that is the most, that's the way FRAX was designed, to use the femoral neck. And then finally, you're going to ask, how often should we DEXA scan a patient? It does vary. It's a very case-by-case situation. It may vary depending if you started a new treatment. You may want to monitor the treatment started working within 18 months to 2 years. Generally, less than 18 months, I never do a DEXA scan unless I'm really worried, potentially in a young patient who's been rapidly losing bone. I may do it in 12 months. But generally, 2 years at the earliest, sometimes 18 months. So here is a graph of several thousand postmenopausal women and their transition into osteoporosis from normal and osteopenic bone. So on the y-axis is your cumulative incidence of osteoporosis, so what percentage developed osteoporosis over the time since baseline, okay? So, for example, if you see people with advanced osteopenia, so that's -2 to -2.5 in the red, within about a year, 10% have gone to osteoporosis. Okay, so that's a group that you may want to do a DEXA scan in, within the next few years. However, if you look at someone with mild osteopenia, okay, so osteopenia, so they may be worried their bones got low bone mineral density. I'm worried I'm going to go into osteoporosis. They've got a t-score of -1 to -1.5. And so this is the light yellow line. And here it takes them over 16 years to develop osteoporosis. Okay, so the two ends of the spectrum of osteopenia, there's quite a big difference in their rapidity to onset of osteoporosis. And then if you have normal bone mineral density, it's very similar to actually just having very mild osteopenia. So in general, worry about people on the borderline, but don't really worry about people with the very mild osteopenia unless they have lots of additional risk factors. you will often get a patient coming to the clinic who will just present you with a scan that they had done privately or abroad and say, oh, I'm really worried about my bones. And this is your opportunity to try and calm them down, make them feel better about their bone health, in terms of the bone mineral density is only up to 50% of the actual strength. If you haven't fractured, it's probably even less representative of their fracture risk. If they've just got mild osteopenia, it can take over a decade for them to develop osteoporosis. So that is where I will leave it today. On our next session, we will talk about how to decide if a patient needs treatments. And then, quite pertinent to today's further talks, we'll also talk about the impact of steroids on bone. Thank you very much.
Answer while they're asking, which is, how do you manage patients with osteopenia or normal BMD who have fragility fractures by definition?
Hi, DT, that's a very good question. Obviously, as I said, most fragility fractures do occur in this cohort that have osteopenia and normal bone mineral density. And this is where FRAX really comes into its own. So FRAX was designed predominantly to help decide what to do with the osteopenic patient. With osteoporosis, most people will treat them. In fact, in America, the guidelines will say if you've got minus 2.5 or less, you treat no matter what. In the UK, it's more FRAX dependent, so it's not necessarily if you have osteoporosis, but it's about your fracture risk. So what I would do in osteopenic or normal bone mineral density patient who has a fragility fracture, I would enter their numbers into FRAX, which I'll do next session, and then that will give me an approximate risk for them and determine treatment. But most likely, if someone's having fragility fractures, that's a bad sign, and they probably warrant treatment.
Okay, so let me share my own screen. There's a question about bilateral hip replacements. Then what do you do for hip FRAX scoring?
Yeah, that's very good. Good question. I haven't had that problem yet, but what I would do is I would put the lumbar spine in. Now, you'll have a lot of patients where you will find that their lumbar spine is much worse than their hip. Partly because all the metabolic disturbances affect the trabecular bone, or the cobweb bone, which is more predominant in the spine than the hip. You can do a correction for these patients. So for every one standard deviation worse that the spine is than the hip, you can times your FRAX risk by 10%. So I would probably put the lumbar spine into there.
Okay.